All right, this is for Chemistry CP, debrief on drawing Lewis dot structures homework that had been assigned on February 3rd. Yikes. So, as we develop these Lewis structures, first of all, we need to establish how many valence electrons there are. Looking at nitrogen, it always has 5 valence electrons. There are 2 of those. 5 times 2 is 10. Each hydrogen always has 1 valence electron, so the total is 14 electrons. And following some sort of rules, we should put the nitrogens in the center with the hydrogens attached to the nitrogens. So right away, I'm just going to go and write the hydrogens like this, put at least a single bond between the 2 nitrogens, and a hydrogen, 2 hydrogens to each nitrogen. So how many electrons have I just used up? Each dash represents 2 shared electrons. So 2, 4, 6, 8, 10. I've used up 10 of my electrons. That means I have 4 electrons left over to distribute somewhere. The hydrogens are happy. They have the 2 that they care for, and that's it. As for the nitrogens, 2, 4, 6, each nitrogen only has 6 electrons. If I provide 2 additional electrons to each of the 2 nitrogens, that uses up the 4 electrons I still need to use up, and it makes each nitrogen satisfied with a total of 8 electrons. 2, 4, 6, 8. 2, 4, 6, 8. Who do we appreciate? Chemistry. All right, so from my point of view, this is the solution for N2H4. Next, we have a polyatomic ion, PO4 with a 3- charge, which I believe is called the phosphate polyatomic ion. Phosphorus has 5 valence electrons, and oxygen has 6 valence electrons. 6 times 3 is 18. 6 times 4 is 24, plus 5 is 29, and this net charge means there are 3 additional electrons. So I have a total of 32 electrons that I need to accommodate. I would put the phosphorus in the center of the group, surround it with 4 oxygens with a single bond to each one. That takes care of 8 of my 32 electrons, leaving me with 24 electrons to distribute. The phosphorus, from my point of view, is very happy. It's got its 8 electrons. Each oxygen could use 6 additional electrons. There's 4 of those. And the way I would have done this is put 6 dots around each oxygen. And say, look, I've used up my 32 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Ta-da! Put square brackets around this whole structure to inform the world that it has a net 3 negative charge. And based on my understanding of chemistry CP, I would have accepted this as the solution. However, many of you went on the internet and Googled a solution, and the solution that you came up with on the internet is quite interesting and different. When you go online, you'll see that there's a solution that is not this. It says essentially, and I have to do a kind of miniature, yes, the 4 oxygens surround the central phosphorus. However, one of these oxygens has a double bond instead of a single bond. That particular oxygen has 2 fewer dots, so it still adds up to 8 for this. 2, 4, 6, 8. The other Oxygens still have 6 dots around them. This structure still has a 3 negative charge, so it goes inside of brackets. And on the internet, they explain, well, this makes it a bit more stable configuration than what I would have taught you. Here's what I would have taught you and what I would have expected as a solution. Here's what Lord Google says when you talk with a higher level chemistry instructor or listen to an 11-year-old on YouTube explaining it to you. And what I don't like about this is that it has 10 electrons around the phosphorus, 2, 4, 6, 8, 10. And I would never come up with this myself. But some of you drew this and said, oh, here's, what I came up with, really. Well, the thing of it is, if you draw this structure, then really you should be aware that you need to draw all of its resonance structures as well, which means it's not only the oxygen on the left that has a double bond, but you need to draw 3 additional times, shifting that double bond with all the appropriate dots and the brackets and the 3 minus charge for all 4 drawings. And by the way, when you draw just a dash with no atom identified at the end of it, it's implied that it's a hydrogen at the end of that dash. So you have to write the oxygens in. And again, now the double bond goes below. And I'm not writing all the dots, I'm just telling you, look, you're going to have to fill in all the dots, draw all 4 resonant structures if you're going to use this solution that you pull off the internet, showing that you understand that it's not just the left oxygen, but it's a blending of each of the 4 possible situations. So, yikes. I kind of view this whole solution as being a little bit beyond what I would have expected us to encounter in a Chem CP course. For the next one, chlorine and oxygen put together. Chlorine has 7 valence electrons, oxygen has 6. 7 plus 6 is 13. Now add 1 more electron, and we have a total of 14 electrons that we need to accommodate. Chlorine, at least a single bond to an oxygen, takes care of 2. We have 12 left to take care of, and I would divvy them up evenly. 2, 4, 6 on the chlorine, 2, 4, 6 on the oxygen. We now have our 14 electrons, 2, 4, 6, 8, 10, 12, 14. This entire structure is to be drawn within square brackets with a 1 minus superscript on the outside, indicating that this is a polyatomic ion with 1 more electron than it has protons. Carbon dioxide. Carbon has 4 valence electrons. Oxygen has 6 valence electrons. 6 times 2 is 12. 12 plus 4 is 16. So we have a total of 16 electrons to accommodate for our carbon dioxide. Put the carbon in the center and oxygen on either side of it. And one thing we can do here is create double bonds to keep the carbon pretty happy. So the carbon now has 8. So we've used up 2, 4, 6, 8 of our 16 electrons. That means we have 8 electrons to take care of. I would split them evenly amongst the 2 oxygens. So I put 4 electrons on the left oxygen, 4 electrons on the right oxygen. It's stylistically unimportant whether you make the dots align the way I did or on the side instead of on the top or on the bottom. However, do not put a single dot on one side of the element symbol and a single dot somewhere else. You should always represent them as pairs of dots unless you have genuinely one single electron in some situation. So look, 2, 4, 6, 8, 10, 12, 14, 16 electrons. This is carbon dioxide. Next, CO3 with a 2 minus overall charge for that polyatomic ion. Again, carbon has 4 valence electrons. Oxygen has 6 valence electrons. 6 times 3 is 18. 18 plus 4 is 22. Now add 2 additional electrons. 22 plus 2 is 24 electrons total that we have to accommodate. In this situation, I would put the carbon in the center, an oxygen off to each side, and either I put a lone pair of electrons on the carbon, or much more likely, I'm going to end up wanting to do a double bond between one of the oxygens and the carbon. So at the moment, I have 2, 4, 6, 8 electrons taken care of. The carbon is happy and satisfied. I have 16 more electrons to take care of. 24 minus 8 is 16. And I would divvy them up first over here. So 2, 4, 6, 8, 10, 12. And then over here, I would go 14, 16. There, look, slightly different style. This gives me my total of 24 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. This is a polyatomic ion, so put it in square brackets with a 2 minus charge. And so here's the deal. You need to show the resonant structures. And by the way, with the resonant structures, we draw it with double-headed arrows going between the alternate structures. This has resonance as well. So with a double-headed arrow, I should draw carbon with a single bond to the left, double bond up, single bond to the right, and then all the dots 2, 4, 6, 2, 4, 2, 4, 6, square brackets, 2 minus charge on the outside. And third possibility, so another double-headed arrow, carbon in the middle. This time put the double bond on the right. Square brackets, 2 minus charge, and this is what you should draw. Now, if you drew it at 120 degree angles instead of 90 degree angles like I did, that doesn't bother me in the least. What does bother me is if you write just one of these that you figured out, you really need to show the resonant structures that says, well, it's a blending of sometimes this oxygen is the double bond, sometimes it's that one, sometimes it's the other one, and they're pretty much equally distributed in possibilities of the combination that you deal with. All right, now this next one, NO3. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. 6 times 3 is 18. 18 plus 5 is 23, but there's an extra electron. So again, we have 24 electrons. Try putting the nitrogen in the center, surrounding it with 3 oxygens. And now what? Well, it's really the same story as carbon in a sense. We have 24 electrons, and we're going to look at going in the direction of putting a double bond on one of these three oxygens. So again, I've used up 8 of my electrons. Nitrogen has 8 around itself, so I would distribute this 16 as before. 2, 4, 6, 8, 10, 12, 14, 16. Square brackets around all of this, and a 1 minus charge, showing that this is a polyatomic ion. As before, this has resonance. There's nothing special about the left oxygen in my diagram. So, double-headed arrow, nitrogen, now single bond on the left. Oh, let's make it a double bond on the right, single bond up. A little bit of variety, huh? 2, 4, 6, 2, 4, 6, 2, 4, square brackets, 1 minus charge, double-headed arrow, nitrogen, double bond up this time, 2, 4, 6, 2, 4, 2, 4, 6, square brackets, 1 minus charge, and you're communicating that you understand that it's an equal blending of these 3 possible Lewis dot structures at any given moment. For SO2, sulfur has 6 valence electrons. Oxygen has 6 valence electrons. So we can think of this as being 6 times 3, right? 6 times 1 plus 6 times 2 is 6 times 3 is 18 electrons total. Putting the sulfur in the center and oxygen on either side, well, so now I have 2 more electrons to take care of than I do with carbon dioxide. So I can't just put 2 additional dots on my SO2 and leave it as double bonds. What I can do is put one of these as a double bond and put 4 electrons on this left oxygen, so it has 8. 2, 4, 6, 8. For the oxygen on the right, add 6 electrons, and it has its 8. So what's my total right now? 2, 4, 6, 8, 10, 12, 14, 16. I still have 2 electrons that I need to put someplace, and the sulfur only has 6 electrons surrounding it. So 17, 18. Here is the way I would write SO2. But it has resonance. There's nothing special about the oxygen on the left. So double-headed arrow, single bond on the left, double bond on the right, and then basically you're drawing the mirror image of this Lewis structure. No brackets because it's not a polyatomic ion. It's a non-metal binary covalent molecule. This concludes the debriefing on this homework assignment.